Hey guys, it's Savannah, and today we're going to be talking about the importance and function of the sodium-potassium pump. As you know, we have the plasma membrane of neurons, and that's what we're going to be talking about today. When we talk about the phospholipid bilayer, we're talking about the bilayer of the neuron cell. As you see here, we have the sodium-potassium pump in between the bilayer, the extracellular fluid, and the intracellular fluid. On the outside of the cell, we have a high amount of sodium, as you can see, Na+, and on the inside of the cell, we have a high amount of potassium, K+. The outside of the membrane has a positive charge and the inside has a negative charge. This charge difference is called the membrane potential and is measured in millivolts. On the inside of the cell, we also have ATP that will be providing us with energy, which will bind to a certain side of the pump. As you can see, the concentrations of both the inside and the outside of the cell aren't perfectly distributed, but there is higher amounts of sodium, higher amounts of potassium. First, 3 sodium ions bind to the intracellular sites of the sodium-potassium pump. Next, the phosphate group is transferred to the pump via the hydrolysis of ATP, and that ATP goes away. The pump then undergoes a conformational change, translocating sodium ions across the membrane. Here is the change of the pump. And here is the release of the sodium ions to the outside of the membrane. Ta-da! They're on the outside of the membrane now. Next, there will be potassium ions going into the sodium-potassium pump from the outside of the cell. Conformational change previously exposes 2 potassium binding sites on the extracellular surface of the pump. The phosphate group is then released, as you saw here, which causes the pump to return to its original conformation. This then translocates the potassium ions across the membrane. Therefore, which will end up completing the ion exchange. And therefore, we have more potassium on the inside of the membrane of the neuron. Of course, once again, there is a higher concentration of sodium on the outside of the membrane and higher concentration of potassium on the inside of the membrane. The sodium-potassium pump also maintains the membrane potential of the cell at rest, which is also called resting potential. The membrane potential of a cell, or the resting potential, is supposed to be maintained at about -70 MV, which of course is also called millivolts. The negative sign indicates that the inside of the cell is more negatively charged than the outside, and that is the sodium-potassium pump.